over its result, meaning the derivative, is valid. Okay, so first thing you want to do is figure out what is the domain of the original logarithm. Okay? Because it's not just ln x anymore, it's ln x squared. If it were just ln x, I would automatically know it's just real numbers. It's 0 to infinity, not inclusive. But now it's ln of x squared. So, what can you not put into a logarithm? What kind of number can you not put into a logarithm? And? Negative and 0. So what you need is to find out where is x squared positive. Where is x squared positive? What's that? You're close. Not 0. Everywhere except 0. Okay? So the domain of ln of x squared is going to be all reals except 0. Agreed? Because no matter what you put in here, the square is going to make it positive, except for the 0 case. And so then you're really just putting a positive natural log, and that's just fine. Except for 0, you put 0 in here, it squares it, makes it 0, and you have ln 0, which is meaningless. Because it's not defined at 0, that's where its asymptote is. Right? Okay? So now when we differentiate this, we take the derivative. It should be the same domain of validity for the derivative. So now, what is the derivative of ln x squared? All right. What do you say? Except it's a chain rule. You're right at first. It's a chain rule because it is a function inside of it's an x squared inside the natural log. So d dx of ln x squared. Chain rule demands derivative of outer function 1 over x, but I leave the inner function the same. So response is correct, 1 over x squared. But now I must take the derivative of the inner function. What's the derivative of the inner function? 2x. So we get 2x over x squared, which is 2 on x. Okay?
Wait, why is it just x squared and not ln in the inside?
I mean, why not the ln b?
Yeah.
Because since it's the natural log has the special case which is 1 on x. Because e is the base, ln of e is 1, so it doesn't show up in the formula, you might say.
Won't the derivative of ln just be 1 over x, not 1 over x squared?
Yeah, but you keep the inner function the same. Derivative of outer is 1 on x. But when you take the derivative of the outer, you keep the inner function inside of it. So that's an x squared inside there. And then you multiply it by the derivative of the inner, which is 2x in this case. Any question about problem 1? Maybe the first one we've done today. That's what problem 9, I guess. Next, let's do another one. 11. Derivative of the natural log of a quotient. The quotient is x plus 1 over x minus 1. Whew, this is getting tricky already. It's domain business. So what I have to guarantee, I've got to find out where x plus 1 over x minus 1 is greater than negative by at least a smidge. So yeah, greater than 0. Okay, so we have to solve this rational inequality, which you probably do not remember how to do. Probably don't remember how to do that offhand. Maybe some of you. How do you solve rational inequality? First of all, we are glad it is a 0 over here. If it was not, we'd want to make it 1 anyway to solve this small problem here. Okay? So what do? You need to find the zeros of the numerator and the denominator. What are the zeros of the numerator? Okay, what's the zeros of the denominator? 1. All right. You want to plot those on a number line. This is how you do polynomial inequalities and rational inequalities. The reason we didn't do it for this polynomial here is because it was such a simple case to think about. this is not as easy to think about, so I'm going to do the formal process you learned in pre-calc. All right, so all we do is take test cases now. The way it works is this. I split the real line into 3 intervals. So if I take a test case from here and I plug it in, if it makes it greater than 0, it makes it positive, then it's positive along this entire interval. If it makes it negative, it's negative along the whole interval. All right? And these are the only 2 places where it's ever going to be, well, 0 or undefined. All right? That is where it's not positive or negative. On every other interval here, it's either always positive or always negative, always positive, always negative, always positive, always negative. We just got to figure out which one. So take test cases. Pick a negative number that is more negative than -1.
-2.
Okay. If you plug in -2, is the top negative or positive? Is the bottom negative or positive? Negative or negative is?
Positive.
So therefore greater than 0 or less than 0?
Greater.
Greater. All right. So that is going to be a keeper, right? Those x's we're going to keep in the domain because they make this expression positive. So it'll be ln of a positive, which is legitimate. So now you go to the middle case. Pick a number between -1 and 1. I know what you think. All right. Plug in 0, you'll get 1 over -1. Negative or positive?
Negative.
So therefore, the entire interval in here is negative. Now you take a number bigger than 1.
2.
What do you think? Positive or positive?
Positive.
So positive. So we need to keep what? What's the domain here?
Negative infinity to -1, 1, 2.
Negative infinity to -1. Inclusive or exclusive?
Inclusive.
Inclusive? Exclusive.
No, exclusive.
Right, because -1 makes it 0, which is no good, right? 0 is not greater than 0. And I can't take the 1 either. Matter of fact, whenever you're doing the log problems, anything you're plotting on this number line, you're never going to use, right? Because they either make it 0 or undefined, which is no good for log. Meaning they make the x 0, or they make the input 0 or the input undefined, which is no good. All right? And then you said 1 to infinity, so there is our legitimate domain for this function. Rational inequality, everybody's okay, right? You guys remember that or not? Did you bring back memories from pre-calc at all?
Yeah.
Bad memories or?
Bad.
Bad, all right. So now we need to take the derivative. If it were just x, it'd be 1 on x, right? So what's the derivative of log? It is the reciprocal of what's inside. So I think it would be foolish right now to write equals 1 over, I know I'm writing something I said was foolish, whatever. I think it's foolish to write that. Because what are you going to do in the next step? You're going to flip it. Because that's what this says, right? Whatever's inside the log, you're taking the reciprocal of. So I should just write from the beginning x minus 1 over x plus 1, okay? Now that's the first stage in the derivative, right? That's outer function log differentiated with inner function left inside. Now I need to take derivative of x plus 1 over x minus 1, all right? And I got to use a quotient rule on that. There is something else you could do, but I don't waste your time with it.
You're multiplying it by that?
Yeah, this completes the chain rule, right? That's derivative of inner.